All right, so in this video, we are going to learn about how to calculate the rate of change, aka slope. Now, the idea of slope is the steepness of a line. So any and all lines would have a type of slope, right? It tells you how steep is this. Now, the idea of how do we measure slope, we think about it as rise over run, okay? Rise over run is basically how much is going up by over how long it's going over by, okay? Now, in this case right here, we are going to learn how to calculate the slope. I like the intuitive method, but for the sake of consistency, we are all going to use the slope formula, right? So m, which is standing for slope and or the movement of something, is y2 minus y1 over x2 minus x1, okay? So with that said, what you have to do in order to extract the slope from a table and or coordinates is simply actually extract the coordinates from the table that you see. So I have two different styles of table. Sometimes they'll give you a horizontal table, sometimes they'll give you a vertical table, but the idea is always the same, okay? So what you want to do is select two coordinates. Now, sometimes they'll be very specific with the coordinates that you have to select, but other times you can just select two coordinates, right? Let's just say I wanted to know what the rate of change is from year 3 to year 6 or something like that, right? So in this case, right, I would actually select this coordinate and this coordinate because it represents year 3 and year 6, right? Assuming x is years and y is like growth of something, right? So in this case right here, because this is x on top and then y, I'm gonna rewrite the coordinate as 3, 10. And I'll rewrite the second coordinate as 6, 16, okay? Now, very important, you have to label your coordinates, okay? All coordinates occupy the form of x, y. So in this case right here, because this is the first coordinate, we're going to call it x, y. But to allow us to understand the difference between the first coordinate and the second coordinate, we're going to call this x1, y1, and the second one as x2, y2, like that. And then all we have to do is simply apply the formula, okay? So y2 is 16 minus y1, which is 10, over x2, which is 6, minus x1, which is 3. In this case right here, we just do the simple math. 16 minus 10 is 6. 6 minus 3 is 3. And therefore, my slope is going to be 6 over 3 or 2 over 1, right? Or simply 2, okay? Either way, it means the same thing. The movement from one coordinate to the next coordinate, right, in order would be 2 over 1 or 6 over 3, etc., etc., okay? So let's do it one more time, but this time with a vertical table. It's the same idea, but it's going to be obviously a different type of slope because I use different coordinates, right? So for example, let's just say I wanted to find what's the movement slash rate of change slash slope from year 3 to year 4. Not year 3 to year 4, year 3 to year 6, right? I'm going to select year 3, I'm going to select year 6, and just drop the coordinate. 3, 4, 6, 13, and as always, I'm going to label properly x1, y1, x2, y2, okay? Once I've labeled, I'll just apply the formula, which is already up top, y2 minus y1 over x2 minus x1. So y2 is 13 minus y1, which is 4, over x2, which is 6, minus x1, which is 3. And then all I have to do is subtract. 13 minus 4 is going to give me 9. 6 minus 3 is going to give you 3. And 9 divided by 3 is going to give me 3. Therefore, my slope is equal to 3. And that's how you calculate slope or the rate of change for a table / from a set of coordinates.